Okay, so hello grade 8s. Today we're going to be doing graphing and interpreting data. So please can you go to page 21 of your booklet and put in the date of today. So whether it's today, the 23rd, or whether it's tomorrow that you watch this video, just make sure you put that in the dates because we will be checking your booklets to make sure that you are actually putting in this information. So let's just start with an introduction. This entire section is about how you are representing information. That is what it's about. Graphs are for representing information. Why do we use graphs and we don't use, for example, narrative or a piece of writing? Because people think in pictures. It's just a lot easier to use a graph than to write an entire paragraph about what you found in a study. So it helps us visualize things because we like pictures. As human beings, we like pictures. Okay. So a perfect graph would be a graph that shows all the information. You wouldn't even have to read the paragraph to see what is it about. Okay. So at the top of the page where it says graphs are very useful tools in science, they can help you visualize a set of data. With a graph, you can actually see what all the numbers in the data table mean. So this means that if you've got information in a table, you're now translating it into a picture. So in that little space that you have in your book, I want you to say numbers are represented visually by a line or by bars. Now, in physical science, we use line graphs. We don't use bar graphs. In biology, you guys are going to use bar graphs. And you're going to see why, because we like to see what the relationship is between two variables. So the two common types of graph in science are bar graphs and line graphs. And each type of graph is suitable for showing a different type of data. So depending on the information you have, you need to choose the type of graph you are going to use. Okay, so make sure that you fill that in. And then in the next slide, we're going to carry on with types of graphs, and we're going to start with line graphs. Okay. Okay, so types of graphs. The first type of graph, like I said to you before, is the most common. It's the one we're going to use the most in science, and it is going to be the one you guys need to know like super well. So line graphs show a relationship between two variables. So I want you to look at that picture, and it's in your book as well. Look at that picture there. You have the world population on the y-axis. That's where you put the dependent variable. And then you have the year, which is the time, on the x-axis. This is the independent variable. And as you can see, as the time goes by, the world population is increasing. So this type of graph is showing changes over time, but it's not looking at 1 year by itself. It's looking at a continuum spectrum. Okay, so it's looking at how does that variable on the y-axis, change over time. And line graphs are used to check changes of periods of time. When the smaller changes exist, line graphs are better to use than bar graphs. Okay, they're far more accurate. So for science, for physical science, we want you guys to use line graphs. For bio, you guys are probably going to use bar graphs. Nothing wrong with bar graphs. It's just we use more relationship data than what they do. Line graphs can also be used to compare changes over time, over the same period of time for more than one group. So what does that mean, grade 8? What that means is I can have two sets of data or two variables on one graph. So I could have the world population on Earth and the world population on Mars, for example, if we were talking about way in the future. And then what would happen is that graph would just be like two different colors, or instead of using circles for both, you use circles for one and crosses for another. And you would draw a little key in the corner to differentiate it. And we're going to teach you all of this. Like, you should be psyched about this. It's actually quite a lot of fun because now you are putting your information in pictures, and that makes sense. It makes a hell of a lot more sense than words. At the bottom of the page, it asks you about the accuracy of the graph. So I want you to look where the time stops. The time stops at 2020, and then it carries on going. So what this graph is actually doing is it is actually predicting how the world is going to, the population is going to grow after 2020. We don't know that. So this is inaccurate. It is invalid. You cannot do that. That's not right. So the accuracy is the validity of the data is accurate up to the year 2020. After that, it's an estimate. So please write that in at the bottom of the page. Once again, grade 8s, if I'm speaking too quickly or if the video is in progress and you guys need to take a wusa moment so you can fill in, just pause, write it in, and then carry on in your own time. Okay. All right, so pie charts. Now, pie charts are very interesting. I want you to think of a pie in front of you, and you've got some people get the big piece and other people get the small piece, just depending on who's the one that's doing the cutting. The pie chart is best when you are comparing parts of a whole. So imagine that the circle represents 100%, and you are comparing of that category or of that study, who got 30%, who got 70%, who got 20%, who got 80%. Look at the first picture. It says the blood types of 25 donors. So what it's done there, it's broken down 100%, and it's saying 20% was type B, 28% was type A, and each of them have different colors. So this is nice when you're looking at parts of a whole. So the slices show the piece of 100%, the percentage of 100%. The same goes for the picture next to that, where we're looking at homework that you guys would have to do. Now, obviously, its majority is going to be orange because none of you ever do homework. Look at the three categories. We got does homework day, does the homework in the day it's assigned. So that means that a very small amount of you are going to do your homework on the day that we give it to you. Then it says, does homework right before class? Okay, that's a bigger part of you. That's more common, I think. And the last one is, did we even have homework? A lot of you guys ask that question all the time, and majority. So I think that graph is super accurate. Like, it's got grade 8 mentality down. Okay, so I hope this makes sense. All you got to think of is 100%, think of a pie, and think of parts of a whole. Okay. All right, so this is our favorite, or one of our favorites. It's the bar graph, okay? And this shows differences or comparisons between categories of data. So not how the variables relate as much as, or the relationship of the variables. It's more about how the categories can be compared and how they overlap. So let's look at the picture we've got there. We've got birthday of students by month, and then we've got the number of students on the y-axis. So on the y-axis, we have a numerical value, and on the x-axis, we have a actual category. So January can be considered a category. February is a category. March is a category. Okay, what is the category? The category is month. So the bold word is it actually represents the category, and then the ones that are closest to the line of the scale, that is your subcategory. All right, so it's categories that are being compared. It's very important, grade 8, that you recognize that these bars do not cross at all. That's a histogram. That's when we're looking at numerical information. Bar graphs are for categorical information, and we do not let them touch whatsoever. Okay. I want to just say something. This type of information, you need to know it in your books. We will ask you in the exam, but I'm not going to expect you to draw a bar graph. Okay, you don't have to draw a bar graph at all. I'm going to want you to draw a line graph, and that is what we're going to get you to practice the most. So the histogram. The histogram is a little bit different from the bar graph, because now if you look at the x-axis, guys, what do we got there? We don't have categories, we don't have months, we don't have months and time. we have numerical information that's on a continuum. It's moving. So you've got categories of the age from 0 to 19. Then you've got 20 to 29. Then you've got 30 to 39. So these are age categories, but they're in ranges. So that's a nice way to think of it. They're in ranges, numerical ranges. Okay. And these are plotted against the number of winners. So both is numerical. The difference is that the one is continual and the y-axis is absolute. Very important here, the bars do touch each other. The horizontal axis is continuous. Everything I've said now is basically on the slide. So while I'm talking, I want you to highlight the most important things, which is that the bars do touch and that the axis is continuous and it's numerical in nature. Okay. This is just a summary slide to consolidate exactly what I've just said, just so you guys can get it in your heads. And it's the bar graph versus the histogram. So look at the bar graph. It's got gaps between the bars, all right? And it's categories, absolute categories, with subcategories. And the histogram, there's no gaps and there are number ranges on a continuum. So those are the two big differences. So you guys can write it in the corner for yourself, make little notes. I tell my class all the time, I'm like, write in your notes. Make little reminders in the margin. The more I see that you've written or you've drawn, then that tells me that you are actually working. If I don't see anything and you've got beautiful notes, then are you really working? That's the question. Okay, so we're going to carry on now onto the next section, which is going to be a scatter plot. All right, so I know this looks scary, and you're probably freaking out, so just calm the farm. It's going to be okay. The scatter plot represents points that correlate. When you look at that, the graph in front of you with the height and the weight, it's looking at how height and weight correlate. Every dot represents an individual or represents one participant in the study. What can you see there? What is the general trend? What you're seeing is that as the height increases, so does the weight. And that makes sense if you think about it. If you have a heavier frame or you are taller, you are going to weigh more. Okay, you're going to have more mass. You're going to have more meat on your bones because your body has got longer bones, denser bones. All right, so that makes actually sense. Anyway, that's on a separate issue. The important thing here is I want you to look at what is the trend? Where are those dots going? They're both increasing. And it's quite a very strong positive correlation. All right, so it's measuring one event. So look at my bullet points. The scatter plot graphs are used to determine relationships between two sets of data. So you've got the weight data, the weight of that person, and you've got the height of that person. And how do they correlate? How do they match up? Okay. So it's the x-axis is used to measure one event or variable, and the y-axis is used to measure another. In this example, each dot shows one person's weight versus their height. Data is plotted on a graph. I'm sure you've recognized the y and the x coordinates. You guys do this in maths. This should be super easy. But once again, I'm not going to expect you to draw this, but you need to know that it exists. So please, if you're getting stuck, drop me a message and I'll help you out. Right, so this is our final slide for this video. And I want this has got to do with the correlation. This is how these two variables relate to each other. That's what it means. So you don't need to know the numbers at the bottom of the graph. So these things over here, let me see if I can use my highlighter. These here, you don't need to know those off by heart. That's got to do with p-values and correlations. And that's got to do with stats. You guys don't do that yet. But it might help you to look at that to see how the rest of the graph works, because the picture works together. Everything in the picture works to communicate the results. So let's look at the first one. The first one is perfect positive correlation. That means that as one increases, the other one increases at the exact same rate. Then you've got a high positive correlation. Can you see that those data points are not completely 100% the exact same thing? A low positive correlation means that the points are more dispersed. There's no actual trend, and no correlation. It's just chaotic, like nothing is working together. And then on the opposite sides of the spectrum, so that would be for direct proportionality. That means as one variable increases, the other one increases. For inverse proportionality, we look at as one variable increases, the other one decreases. So a low negative correlation is going to be that they don't really fit together. There isn't much of a relationship of as one increases, the other one decreases. High, there's more things are coming in, making sense, and they are actually working quite closely together. Working on opposite ends of the spectrum, but there is some relationship. The perfect negative correlation is when, as one increases, one is decreasing at the exact same rate. Okay, so for grade 8 level, all I want you to know is that if both variables increase at the same time, they have a positive relationship. If one variable decreases while the other one increases, they have a negative relationship. Okay, I really hope this makes sense. I really hope I've helped you. I'm going to stop this video now, and I'm going to work through the next one, and you're going to love it.